Hello, everyone. In a world of science that was almost entirely dominated by men at the end of the 18th and the beginning of the 19th century, the brilliant scientist Marie Curie shone brighter than anyone. She broke through every barrier of prejudice, becoming a radiant symbol of intelligence, determination, and extraordinary perseverance. She was the first woman in history to have the honor of receiving 2 Nobel Prizes in 2 different fields, physics and chemistry. Marie Curie's career left an indelible mark on the history of humankind. However, what made her truly great was not only her remarkable scientific achievements, but also her noble character and selfless devotion. Between fame and personal gain, Marie Curie chose the path of science. She willingly shared her precious discoveries with humanity, instead of keeping them for herself. It was this wholehearted dedication and genuine passion that made her an immortal legend in the scientific world, as well as an endless source of inspiration for generations to come. Let us embark on a journey to explore the life and legacy of the extraordinary scientist Marie Curie, the woman who dared to shine in a world ruled by men. How did she strive and rise above all challenges? What great legacies did Marie Curie leave behind for future generations, especially her groundbreaking discoveries in the field of medicine? All of these will be revealed in the following chapters. Marie Curie, born Maria Sklodowska in 1867 in Warsaw, Poland, was the daughter of Władysław Sklodowski, a devoted teacher who loved his family deeply and always encouraged his children to pursue knowledge. From an early age, Marie displayed remarkable intelligence and an insatiable passion for learning. She consistently excelled in her studies, ranking at the top of her class in subjects ranging from mathematics, history, and literature to foreign languages such as French and German. Yet Marie's childhood was far from peaceful. At the age of 10, she witnessed the death of her sister Zofia from an infectious disease, and not long after, her mother also passed away from tuberculosis. These successive losses did not break her spirit. On the contrary, they forged within her an iron will, an unyielding desire to learn, to study, and to rise above hardship through knowledge. In 1883, at just 15, Marie completed her secondary education and graduated at the top of her class, an extraordinary achievement for a girl of her time. However, her path toward higher education was soon obstructed by the constraints of society. Poland was then under Russian rule, and women were forbidden to attend universities. Society believed that a woman's place was in the home, to be a wife, a mother, and a caretaker, while fields such as mathematics, physics, and chemistry were reserved for men. Women who dared to pursue knowledge were often ridiculed as eccentric and rarely recognized, no matter how gifted they were. Denied entry to formal universities, Marie joined the Flying University, a secret educational institution for women that taught subjects banned by the authorities. It was a rare light amid the darkness of oppression, offering Polish women access to the sciences and humanities that would otherwise be denied to them. Outside her studies, Marie worked as a governess to support herself, though her earnings were meager. Because of the family's financial hardship, she and her sister Bronislawa, called Bronia, made a heartfelt pact. Marie would remain in Poland, working and studying on her own, while sending money to help Bronia study medicine in France. Once settled, Bronia would in turn assist Marie in coming to Paris to continue her education. At 19, Marie took a position as a governess for a noble family in the countryside. Life there was hard, yet her thirst for knowledge never dimmed. In a letter to her cousin, later quoted by her daughter Eve Curie in Madame Curie, she wrote, "Here people think only of pleasure. As for me, if I stop learning, I feel empty. Even when busy, I find time to read, to do mathematics, to train my mind. When I grow weary, I solve problems in algebra and trigonometry to keep my thoughts sharp." Those words reveal a soul of extraordinary determination, one that refused to bow to adversity. After years of tireless effort, Marie's dream of Paris finally came true. In 1891, at the age of 24, she left Poland for France and enrolled at the University of Sorbonne, one of Europe's most prestigious institutions. At first, Marie lived with her sister Bronya's family, but the long commute and travel expenses proved burdensome. She soon moved to the Latin Quarter, the vibrant heart of Parisian student life. Her student years were marked by hardship and deprivation. To save money, she survived on bread and tea, wore the same worn clothes day after day, and spent nearly all her meager income on books and study materials. She tutored in the evenings to make ends meet, but the combination of poverty and relentless study often left her fainting from exhaustion. Beyond financial struggle, Marie also faced linguistic and academic challenges. Her self-taught French made it difficult to keep up with lectures. Yet, through sheer perseverance, she overcame every obstacle. Within just 2 years, she graduated first in her class in physics, 1893, and the following year earned a degree in mathematics, 1894. An extraordinary feat for any student, let alone a woman in that era. During her search for a laboratory to facilitate her research, Marie Curie met Pierre Curie, a talented French scientist, through the introduction of Polish physicist Joseph Kowalski. Through numerous conversations and academic exchanges, a special bond gradually formed between the two passionate seekers of knowledge. Pierre soon became enamored with the woman whose stern appearance concealed an extraordinary inner fire. After some time, he proposed to her, but Marie refused as she intended to return to her homeland, Poland, to become a teacher after completing her degrees in physics and mathematics. Understanding the aspiration of the woman he loved, Pierre Curie boldly declared that he was willing to accompany her back to Poland, even if it meant giving up his scientific career to become a French teacher. However, an unexpected turn of events changed everything. In the summer of 1894, Marie returned to Poland in search of employment, but was rejected by Krakow University solely because she was a woman. The news devastated her, but it strengthened Pierre's resolve. He wrote Marie a heartfelt letter urging her to return to Paris and continue her scientific pursuits. In response, Marie encouraged Pierre to complete his doctoral thesis. Motivated by each other's determination, Pierre successfully defended his dissertation on magnetism in March 1895 and was appointed professor. That same year, the two married in a simple ceremony. No lavish gown, no diamond ring, only love and a shared devotion to science. They became life partners in both marriage and discovery. In September 1897, Marie gave birth to their first daughter, Irene, who would later become a distinguished scientist herself. After becoming a mother, Marie embarked on her journey into the mysterious realm of radioactivity. To support her, Pierre helped her secure an assistant position in his laboratory. There, the couple began studying the invisible rays emitted by uranium, a phenomenon discovered by Henri Becquerel, who had shown that these rays could penetrate solid matter, fog photographic plates, and affect nearby glass plates. During her research, Marie noticed that the mineral pitchblende, which contained uranium, emitted much stronger radiation than pure uranium. She hypothesized that, in addition to uranium, there must be one or more unknown elements responsible for the heightened radioactivity. Her bold hypothesis was initially met with skepticism from the scientific community. Yet the Curies persevered. They crushed tons of pitchblende, dissolved it in acid, filtered, precipitated, and separated the compounds through crude chemical methods. After months of tireless labor, they obtained a black powder that was 330 times more radioactive than uranium and named the new element polonium in honor of Marie's homeland, Poland. The journey did not end there. When they analyzed the remaining solution, they found its radioactivity still extraordinarily high, evidence of yet another, even stronger element. Finally, in 1898, the couple announced the discovery of a second new element, radium, though they were still unable to isolate it in pure form. Pitchblende was an expensive mineral, but Marie realized that the waste residue discarded after uranium extraction, considered worthless by factories, actually contained higher levels of radioactivity than the original ore. This insight allowed her to purchase tons of material at low cost and continue the painstaking work with Pierre. In their cramped makeshift laboratory, they toiled day and night, grinding, stirring, boiling, filtering, and crystallizing, repeating the process thousands of times. Exhausted, their hands blistered and burned by chemicals, their clothes frayed by acid. Neither realized they were exposing themselves to radiation, an invisible danger then unknown to science. After years of relentless effort in 1902, Marie Curie succeeded in isolating pure radium, a groundbreaking achievement that opened a new era for modern physics and chemistry. During this period, the University of Sorbonne awarded Marie a doctorate of science with highest distinction, and in 1903, the Nobel Prize in Physics was shared among Henri Becquerel, Pierre Curie, and Marie Curie for their discovery and investigation of radioactivity. Initially, the Nobel Committee had planned to recognize only Pierre and Becquerel, believing that the prize should be given to men. But thanks to Pierre's firm insistence on acknowledging his wife's contributions, Marie Curie's name was added, making her the first woman in history to win a Nobel Prize. After the discovery of radium, Pierre became particularly interested in its biological effects. He applied a small amount to his skin and observed that it caused burns that took weeks to heal, evidence that radium could destroy living tissue. This experiment laid the foundation for medical applications of radioactivity. In 1901, Dr. Henri Alexandre Danlos of Saint Louis Hospital in France used radium to treat skin lesions. Soon, radium became one of the most precious substances in the world, valued at $100,000 per gram, equivalent to over $1.3 million today. Despite the potential for immense wealth, the Curies refused to patent their discovery. They made their findings public so that scientists everywhere could advance the field without restrictions of intellectual property. In 1906, tragedy struck. Pierre Curie died in a horse-drawn carriage accident on the streets of Paris, leaving Marie alone to raise their two young daughters amid her soaring scientific career. The loss was unbearable. Pierre had been not only her husband but also her confidant, collaborator, and greatest source of strength. In her diary, Marie wrote, "I feel unable to face the future, but I remember what he once said. Even without him, I must continue my work." Though grief-stricken, Marie did not falter. She was appointed professor at the University of Sorbonne, becoming the first woman ever to teach there, a historic milestone for European education. Alongside her teaching, she continued her studies on the chemical properties and radioactivity of radium. In 1911, she published her work on measuring radioactivity, earning her the Nobel Prize in Chemistry, making her the first person ever to receive 2 Nobel Prizes in different scientific fields. That same year, the Sorbonne established the Radium Institute, consisting of 2 laboratories, one under Marie's direction for fundamental research, and the other focused on cancer treatment applications. Yet even at the height of her career, Marie faced relentless gender discrimination. In 1911, she was denied admission to the French Academy of Sciences solely because she was a woman. The council instead chose a less accomplished male candidate, a stark reflection of the deep-seated sexism in the scientific community of her time. Still, Marie Curie never wavered. She continued her research with quiet determination, proving that true talent has no gender, even if it meant enduring relentless public scrutiny and pressure. After her husband's death, Marie Curie faced harsh attacks from the public over her private life. She had a relationship with Paul Langevin, a scientist 5 years her junior and a former student of Pierre Curie. Paul was a married man, but his marriage had long been unhappy. When news of their relationship leaked, the press ruthlessly slandered Marie, portraying her as a homewrecker. Public opinion turned against her fiercely, while male scientists engaged in similar affairs faced no criticism at all. This incident revealed the deep injustice women of that era endured, not only in science but also in their personal lives. Amid the storm of condemnation, the Swedish Academy of Sciences, which was to award the 1911 Nobel Prize in Chemistry, advised Marie Curie not to attend the ceremony in order to avoid further controversy. However, she firmly refused, declaring, "The prize has been awarded for scientific merit. It has nothing to do with my private life." With the support of many honorable scientists, Marie Curie eventually attended the ceremony with dignity and pride. Unfazed by the gossip, she continued her work with unwavering devotion to science, as if nothing had happened. When World War I broke out, Marie Curie devoted all her energy to developing mobile X-ray units, which enabled doctors to diagnose soldiers' injuries directly on the battlefield. She not only conducted research, but also taught herself anatomy, learned to drive, repaired equipment, and personally operated the X-ray machines. As director of the French Red Cross Radiology Service, she tirelessly raised funds, medical supplies, and vehicles for the war effort. Thanks to her dedication, thousands of soldiers were saved. After the war, Marie Curie returned to teaching, continued to lead the radium laboratory, and pursued her research with the same relentless passion. She received numerous prestigious honors, including the Al Richards Research Prize, 1921, the Grand Prize of the Marquis d'Argenteuil, 1923, and the Cameron Prize from the University of Edinburgh, 1931, along with many honorary degrees from universities around the world. After more than 4 decades of research on radioactivity without any protective measures, Marie Curie's health deteriorated severely. She developed aplastic anemia, a form of leukemia caused by prolonged radiation exposure, the very phenomenon she had helped to uncover. In 1934, at a sanatorium in Saint-Célimos, France, Marie Curie passed away. In her final moments, what haunted her was not the thought of death, but the unfinished research she had left behind. Even today, her notebooks, documents, and laboratory instruments remain so highly radioactive that they must be stored in special lead containers, an eternal testament to the sacrifice and devotion of this extraordinary woman. Marie Curie was not only a great scientist, but also a pioneer who laid the foundation for many modern disciplines. Her discoveries, especially in the field of radioactivity, marked a turning point in physics, chemistry, medicine, and industry. Her work allowed researchers to gain a deeper understanding of atomic structure, paving the way for the birth of quantum mechanics, nuclear physics, and atomic energy technology. Her groundbreaking research also became the basis for later scientists such as Ernest Rutherford and Albert Einstein to further develop theories of the atom and nuclear energy. The medical applications of radioactivity have saved millions of lives, from Curie's discovery that radium could destroy cancer cells to the development of radiotherapy, one of the most widely used cancer treatments today. Moreover, her contributions to improving X-ray technology during World War I opened the path for CT scans and PET scans, modern diagnostic imaging tools that still rely on the principles of radioactivity she established. Marie Curie's life stands as a vivid testament to a simple yet profound truth. Great knowledge is not born from comfort, but forged through resilience and unyielding spirit. Born into poverty and raised in an era rife with gender bias and social injustice, she quietly overcame every barrier to pursue the path of science, a path filled with hardship, sacrifice, and brilliance. More than half a century after her passing, Marie Curie's legacy continues to illuminate modern science. She remains an eternal symbol of inspiration for women in science, and a powerful reminder that talent and passion should never be confined by any boundaries, be they of gender, status, or circumstance.